Okay, we are talking about parallel and perpendicular lines in this video, and we are going to be looking at kind of the geometric and algebraic connections here. So we've talked previously about parallel lines. They don't intersect, right? And we looked at something like line A, and it would be parallel to line B. And then that was that symbol for parallel lines. And then we've also talked about perpendicular lines, and those lines do intersect with one another, but they intersect at a 90-degree angle. And the symbol for perpendicular is that upside down T. Okay, so as far as connecting these algebraically as the equations of these lines, we can kind of prove whether or not some lines are parallel or perpendicular looking at their slopes of the equations of these lines if they're graphed on a coordinate plane. So parallel lines, since they don't ever intersect, the slopes are the same. Okay. And what that looks like is if I have a slope that is parallel to another line's slope, it's going to equal the slope of the other line. Okay, so they would be equal to one another. Whereas perpendicular lines, they are intersecting, but they have to meet some special criteria to be considered perpendicular. They have to form a right angle. And so to do that right angle, if the slopes are different, they're just intersecting. So these have to be specifically the opposite reciprocal. Okay. What does that mean? Well, if I'm looking to write a slope that's perpendicular to another slope, it would be the opposite. And notice I don't say negative, I just say the opposite sign, right? So if my first slope is negative, the opposite of that would be positive, right? And then the reciprocal or the inverse is just kind of the flip of those written as a fraction, okay? So let's look at a couple examples here. So in these, when they're in slope-intercept form, I love slope-intercept form because I can identify my slopes really easily. Here's my first slope, it's 2. Here's my second slope, it's -1/2. Okay, notice that these clearly are not parallel. They are, one's positive, one's negative, and one is 2, and that essentially is like 2/1. And so the reciprocal of 2/1 is 1/2. So these are opposite reciprocals, so they are perpendicular. Okay. On this next example, and I kind of just showed you this because we have a slope in this first line of 1/5, and our slope in our second line, so this is just another way to write 1/5. They do this mainly in something like when I'm typing and I don't have an equation editor. It just so I wouldn't be confused like this. If I'm typing this in the sentence, this kind of looks like it might be either 1/5 x or it's supposed to be, 1/5x. So a lot of times they'll just put, when it's a fraction like that, they'll type it in like this, x divided by 5. And so that's the same thing because we can't, get the 1/5 to look like without the equation editor. So anyway, these slopes are both 1/5, and so those are going to be parallel lines. Okay. In this next example, notice my first slope is 4 and my second slope is -4. And so these are opposite, but they're not reciprocals. Okay. The slopes are different, but they don't meet both criteria as our perpendicular lines. So these are just neither, they aren't parallel, they aren't perpendicular, they're just intersecting lines. Okay. So perpendicular lines do intersect, but they intersect at a right angle. And then this last example, these are in standard form. So it sometimes is difficult to tell, looking at these in standard form, this being exactly the same, 2x plus 3y, tells me that this is going to be parallel. But in the off chance that you can't see it, or if they're in standard form and they, don't look exactly the same, that doesn't necessarily mean they aren't parallel. It just means we might need to put them in slope-intercept form. So for rewriting something in slope-intercept form, I'm going to move the 2x to the opposite side. And the 6 did not move. And then I'm going to divide everything by my coefficient of y. And now I can look at this and see that my slope is negative 2/3. Over here on this other equation 2, notice I can do the same thing. 3y would equal negative 2x plus 12. And divide by 3, I get negative 2/3 x, and then 12 divided by 3 is 4. So I can see that the slopes are the same, and these are going to be parallel lines. Okay. All right, in our next example, wanted to write some equations of lines in slope-intercept form, which we are already familiar with, y equals mx plus b. What happens a lot of times is we look at writing an equation of a line through a given point. And in our last examples, we did some where we would kind of rearrange this equation. And we'd say, okay, b equals y minus mx, and then we'd plug things in, and we'd solve for b, and then we'd substitute that back in. And if you're comfortable with that method, by all means, you can use it. But point slope form is something that's nice. We use when we're given a point and the slope. Slope-intercept form we use for a slope and a y-intercept, because that's what we can tell from here. We have a point on the line and the slope. Okay, so our point on the line that we're going to use is just x1, y1. So we're not confused with which one it's supposed to be. Is it y, So x1, y1 is a point on the line, where the line has to go through that point. Okay, and so then our formula is just y minus y1 equals m times the quantity x minus x1. Okay, so let's look at that in action here. So in this beginning thing, we have we're trying to write an equation of a line. It has to go through a specific point, and it needs to be parallel to the line that's given. Okay, so here's our point that it has to go through. So as I'm looking at this, point slope form would be y minus the y coordinate. And then that still kind of looks like an x. Let me fix that. No problem with, I don't know if that's going to fix it or not. Okay, there we go. We'll fix that. Okay. So y minus 5 equals, and then we need our slope, and then x minus 4. Okay, so let's look at this. In our equation, our slope of this equation is 5, so our slope that's parallel to it also needs to be 5. So I'm going to write that right here. So again, I've been asked like, well, wait, where did that 5 and the 4 came from? Remember, this is the point that it specifically has to go through. And then that 5 was the slope. So now all I really need to do is solve this equation. Okay, so I have y minus 5 equals, I'm going to distribute 5x minus 20. And then I just add 5 to both sides, and I get y equals 5x minus 15. And that's my equation in slope-intercept form. So as you can see, point slope form, which I actually like, probably better because it's, in my opinion, a little less work. As long as you can remember what the point slope form is, then it's a little bit easier to kind of do. So let's look at just another example here. In this, we have, notice it's in standard form. And I feel like sometimes standard form can be a little tricky to identify what our slope is. So let's look at putting this in slope-intercept form. Notice it's a minus y, so we'll keep that as a negative y. We'll bring the 3x to the opposite side by subtracting it, and the 2 stays right where it's at. And then we're going to divide everything by -1, and we end up with y equals 3x minus 2. Okay, so I can see that the equation of this line that I've written here in blue is going to be, the slope is +3. So my slope that would be parallel to this line would also be +3. Okay, so what does my equation look like? Remember, it's going to be y minus, and then this would be 3 times x minus, and I need some points. Well, here's my x and there's my y coordinates for the point that the line has to go through. So y minus 2, and x minus 3. And when I go ahead and distribute, I end up with y minus 2 equals 3x minus 9. Adding 2 to both sides, I get 3x minus 7. Okay. All right. Let's do a couple of examples where these both were parallel lines. Let's look at a couple that are perpendicular. Okay. So just to refresh the rule, because this is usually the rule that kind of throws people off, we use this perpendicular rule to get our slope. And the rule is that the slope has to be the opposite reciprocal. Okay. So and this one we're going to look at write an equation in slope-intercept form, and it has to pass through a specific point again, right? And this time the slope's going to be perpendicular to this line. So, the two lines are going to intersect at it's going to go through this point, and these lines are going to intersect at a right angle, a 90-degree angle. So let's look at our equation. So our first one is really easy to see that the slope is 1/2. So the perpendicular slope would be -2/1, which is the same thing as -2. Now I have my x and my y coordinate right here, so I can look at just writing this in my point slope form. So y minus -3 equals our slope of -2 times x minus 4. Okay, and I wrote this all out just so, when we go to simplify here, we get a minus -3. That's going to be y plus 3. When I distribute, I get -2x plus 8. And then I would subtract 3 from both sides, and I'd have -2x plus 5. There's my equation. Okay, in the second example, again, notice we're in standard form. So let's just practice writing this in slope-intercept form. 2y, move the -6x to the opposite side with the opposite sign. Divide everything by 2. I get 3x minus 1. Okay. All I'm really concerned with is the slope of 3, because my perpendicular slope would be -1/3. And now when I use my point slope form, y minus the y coordinate that I have to go through, and then -1/3 times x minus the x coordinate that they specifically want us to go through. Okay, and so then when I simplify this, it's 1/3 times 0 is just 0. So really I end up with, if you notice, this was the y-intercept, and I end up with slope-intercept form. Okay, so that kind of just shows you that, yes, point slope form is where slope-intercept form really derived from. Okay, and slope-intercept form I know we are more common with, but when we're looking at the equation of a line, and a lot of the ones that we do, the y-intercept is always a great starting point. And then from there, we kind of count our slope. 1, 2, 3, 4, went up 4 to the right 1. So it was 4x plus 1, right? Because my y-intercept was 1. If I look at the equation of f of x is a little bit different. This y-intercept we'd have to estimate here. It's not something that works out, to an exact number. So this is where point slope form really does come in handy. It works with any point, right? As I go through, and I could say, here, this is a point. Here's another point, right? Any of these points would work for point slope form. I still do need to know my slope. So my slope here looks like -1/4. So my slope is -1/4. But if we think about this, let's pick a point. I'll just pick this point for now. This ordered pair is 5, 4. So it'd be like y minus 4 and then -1/4 x minus 5. Okay. If I solve this, I could use them with any of the points, but if I actually solve this into slope-intercept form, we'd find out what this decimal was. So we can do that and say y minus 4 equals negative 1/4 x, and then that's going to be plus 5 over 4. And I'm going to rewrite 4 instead of saying plus 4 over here, since it has to have that. Well, I guess I can still say this plus 4. Remember, equivalent fractions, they have to have the same denominator. That's really the same thing as 16/4. Okay? So 16 plus 5, that's 21 over 4. Which is 5 1/4. Or 5.25. Okay, so when you're looking at this, point slope form really does come in handy if you're trying to get an exact equation in slope intercept form that you aren't given your y-intercept. All right, then last but not least, let's talk about if we're looking at two lines and we have the ordered pairs and we're trying to determine the relationship between the lines. So as I look at these, I really want to just find my slopes. So the slope for line 1, we'll use M1. Remember, slope is the change in the y over the change in the x. It doesn't matter which ordered pair we start with. So I could just do, as long as I do y minus y, so negative 4 minus 0, and then I have to start with the same one, the same ordered pair that I started with. So it'd be negative 4 minus negative 3. And that's going to simplify out to negative 4 over negative 1, which is 1. For my second slope, if I did this same way, okay, I'd get negative 2 minus 2 over 0 minus 1. And that's negative 4 over negative 1. And that is, oh, oops, I put negative 1. Or there we go. So that is also 4. So we end up with our slopes of 4 for both of these. So these are parallel lines. Okay. And let's look at the second example. In the second example, for my first slope, and I could start from this point, I could go 3 minus negative 3 over 1 minus negative 2. Just remember, as long as you stay consistent with whichever ordered pair you're starting with. So this ends up being 6 over 3, that's 2. Okay, and then it's always change in y, so 1 minus negative 1 over 0 minus 4. That's 2 over negative 4. That reduces, because when you were first looking at this, it might be hard to see relationship. This is negative 1. So these are opposite and reciprocals, so these are perpendicular. Okay, and so you want to go ahead and do some practice, get more familiar with these rules so that you feel comfortable with them. That's one of the things you're going to have to memorize, and then just being comfortable writing the equations of those lines. If you have any questions, let me know.